Welcome to the DIY Honda Garage channel. This presentation provides an in-depth troubleshooting guide for the DTC code P0340, which indicates that the camshaft position sensor A is not sending a signal. The DTC P0340 specifically relates to the crankshaft and camshaft position sensors, focusing on the CMP sensor A, located near the camshaft to monitor its position. Located within the engine's cylinder head, the CMP sensor A detects the camshaft's position to the engine control module, or ECM, for precise fuel injection and ignition timing. Troubleshooting this code involves verifying the presence of the signal, checking the wiring, connectors, and potentially the sensor or ECM itself. Systematic testing, including voltage, continuity, and ground checks, is essential. The diagnostic process outlined will help technicians accurately identify and resolve the root cause of this sensor signal issue, ensuring engine performance and avoiding drivetrain damage. Preventive maintenance can significantly reduce the likelihood of DTC P0340 reoccurring. Regularly inspecting the wiring harness for damage, corrosion, or loose connections can prevent open circuits or shorts. Cleaning the CMP sensor to remove dirt or debris can help maintain signal accuracy, and replacing the sensor if it shows signs of wear prolongs its service life. Keeping the PCM software updated ensures compatibility with newer hardware and fixes known bugs that could affect signal processing. Monitoring for intermittent faults during routine checkups allows early detection of potential issues, avoiding sudden failures and costly repairs. Adopting these maintenance strategies promotes long-term vehicle reliability and optimal engine performance. In conclusion, diagnosing DTC P0340 requires a systematic approach to identify whether the root cause lies in wiring, sensor, or control modules. Ensuring proper wiring and voltages at each step prevents false diagnoses. If necessary, replacing the CMP sensor or updating the PCM software can resolve signal issues. Proper verification after repairs confirms the problem is resolved, restoring engine performance. Implementing routine inspections and preventive maintenance further minimizes future occurrences. Following this comprehensive troubleshooting guide will help technicians efficiently resolve P0340 faults, ensuring longevity and reliability of the vehicle's engine control system. The first step in diagnosing DTC P0340 is to verify whether the problem is present while the engine is running. Turn the vehicle's ignition switch to the on position or press the engine start-stop button to activate the electronics without starting the engine. Use the Honda Diagnostic System, or HDS, to clear any existing DTCs. Then start the engine properly. After the engine is running, recheck the system for any current or pending DTCs with the HDS. If P0340 appears again, it confirms a duplicated failure. If not, the failure may be intermittent or temporarily resolved, but further checks are necessary for a definitive conclusion. This step ensures that the issue is actively present and helps avoid false diagnoses based on obsolete or stored fault codes. The second step involves inspecting the wiring between the camshaft position sensor A and the engine control unit. First, turn the ignition switch to the off position to prevent electrical hazards. Carefully disconnect the 3-pin connector at CMP sensor A, which is located near the camshaft. With the connector disconnected, measure the voltage between test point 1, which connects to the sensor's wire, and test point 2, which should be grounded. This tests whether the wiring from the sensor to the battery supply holds proper voltage. If testing reveals battery voltage, the wiring is intact. Otherwise, repair the open circuit in the wiring between the sensor and the fuse box, specifically from the B1315A fuse to the sensor's connector. Proper wiring ensures accurate sensor signals and engine performance. Next, determine if the camshaft signal line, known as the cam line, is delivering the correct voltage. With the ignition in on mode and the connector disconnected, measure the voltage between test point 1, connected to the cam sensor wiring, and test point 2, grounded to the vehicle body. The expected voltage should be approximately 5 volts, indicating the sensor circuit is powered correctly. If the voltage is around 5 volts, the signal line is functioning as intended. If not, it suggests a wiring problem or a faulty sensor. This step isolates whether the issue originates from the wiring or the sensor itself, narrowing down the potential fault. In this step, the focus shifts to the low-voltage LG line, which operates in conjunction with the camshaft sensor to provide the engine control module with the camshaft's real-time position. With the connector still disconnected from the sensor, measure the voltage between test points 1 and 2 on the wiring harness platform, targeting the WHT wire on connector number 3. This checks whether the LG line, part of the sensor's circuitry, maintains the proper voltage supply. If the voltage is close to 5 volts, the wiring is sufficient. If not, replacing the CMP sensor A is recommended after verifying the wiring integrity. Proper LG line voltage ensures accurate camshaft positioning signals for engine timing management. This step addresses the possibility of a short circuit in the cam line, which can cause signal issues resulting in the P0340 code. First, switch the ignition to the off position, preventing electrical damage during testing. Using the Honda Diagnostic System, or HDS, introduce a jumper wire across the SCS line, simulating a shorted condition that might exist. Then, disconnect the connector B from the powertrain control module, focusing on the pin accessing the cam signal wire, which is at pin 39 on B connector. Afterward, check for continuity between this pin and ground on the vehicle chassis. If continuity exists, it indicates a short in the wiring, requiring repair of the short circuit. Correcting shorts in the wiring harness is crucial for reliable signal transmission and proper engine operation. The sixth step involves a more thorough inspection of the wiring integrity by testing continued continuity between the signal and ground points. If the wiring appears good, but the code persists, consider updating the PCM software, which can sometimes resolve signal recognition issues caused by outdated firmware. Additionally, substituting a known good PCM unit can help determine if the problem stems from the control module itself. During this process, make sure to turn the ignition off, disconnect the necessary connectors, and perform the continuity tests as previously outlined. If you discover an open in the circuit, repair it accordingly. After repairs or updates, perform the repair verification sequence to confirm the issue is resolved. Once repairs are completed, validate the effectiveness of the troubleshooting efforts through a structured verification process. Reconnect all the connectors to restore the sensor and wiring connections, ensuring they are secure. Using the HDS, exit the self-check mode and reset the PCM, allowing it to recalibrate based on the repaired wiring or sensor replacement. Perform the idle learn procedure, which enables the PCM to adapt to the current engine conditions for optimal operation. Finally, scan the system again for DTCs with the HDS. If the code P0340 no longer appears and there is no pending fault, the repair is successful. This comprehensive verification ensures the problem is resolved and reduces the risk of future engine performance issues. The final step involves a thorough scan for any remaining or newly triggered DTCs after completing repairs. Use the HDS to verify that the code P0340 does not reappear, which would indicate unresolved issues. Confirm that no other related DTCs are present, as they might influence camshaft sensing or signal integrity. Observe the engine's idle stability, acceleration, and overall operation to ensure it runs smoothly, without errors or warning lights. Proper engine function and absence of fault codes indicate a successful repair process. This final check provides confidence that the vehicle's camshaft position sensing system is functioning correctly, essential for optimal engine performance and durability. Please like and subscribe to the channel. See you next time.